I meant to put this on the last video, on the video of the quotient rule, but just neglected to do so. So I'll just go ahead and throw it in as a separate video. This is an application. It says find an equation to the tangent line of this function at x equal 2. Now, first of all, if we know we want the equation of the tangent line, then we need to find the corresponding y value for the function at x equal 2. And that's pretty easy to do. Let's just plug 2 into this function and then find it. So when we plug 2 into this function, in the numerator we get 1 minus 6, which is negative 5. And in the denominator I get 4 minus 5, which is negative 1. So we have negative 5 divided by negative 1, which is 5. So the ordered pair, or the point that we're coordinating here, is the point 2, 5. Now, the other thing we need is the slope. And remember, the slope of the tangent line can be found from the derivative. And so, if you'll remember in the previous video, we found that the derivative of that function up here was actually 13 over 2x minus 5 quantity squared. So if I evaluate this derivative at 2, then that'll give me 13 over 4 minus 5 quantity squared, which would be 13 over negative 1 squared, or 13 over 1, which is 13. So that means that 13 is equal to my slope. So the slope is 13. So I have the slope and I have this ordered pair here. So now I can use this point slope formula and just do y minus the y value, which would be y minus 5, is equal to the slope times x minus the x value. So that would be 13 times x minus 2. And then distribute the 13 and I get 13x minus 26. And then add 5 to both sides to get the y by itself. And then you get y equals 13x minus 21. So y equals 13x minus 21 is the line that is tangent to the graph of this function right here at the point where x equals 2. And that's pretty much all I have on that. Now I'll go ahead and move to the chain rule and general power rule next.